Okay, so this is a Sezam lock, it's a Polish lock, so I'm probably murdering the pronunciation of that, apologies. Yeah, so this is a 4-digit combination lock with a pin tumbler in there as well. So obviously I know the combination to this, which I'll get to in a minute, but here's our key. And if we put our key in when the combination is set to the correct combination, then the key will turn and the lock will operate. Come on. It's a little stiff. And then if we change the combination to something that's incorrect, the key doesn't operate anymore. So there are plenty of videos on YouTube. I say plenty, I think there's 1 or 2 of these showing that this can be picked. It can be picked. It's a fairly trivial pick. It's 5-pin tumbler mechanism, no security pins. It's not that I can feel anyway, but the springs are fairly strong springs, but that's the only sort of thing of any note in there. But nobody's actually decoded this yet. There's no method for decoding the combination, which is what we're going to do today. So before we get into that, I'm going to sort of explain how we're going to do this. So I've got a piece of graph paper. Obviously I know the combination to this. So what I've done is got Yona from the LPU Discord to just give me a random 4-digit number. So that's what this is currently set to, is a 4-digit combo provided by him. It's about the only way I can make this, sort of a way I can show you that I've not picked a combo that works with this method or is, many other kind of cheating going on. Obviously I needed the lock with a combination to figure out the decode method, so here we are. Yeah, this method works with other random numbers as well. Just the one I'm going to show you is this one. So it's currently set to 9593, counting from the top corner here. And each of these dials we're going to decode individually. I say decode, we're going to get it to either a 2 or 4 possible combinations per wheel. So right now the key space is 10,000 possible combinations. The worst we'll get it to is 256, and hopefully half that, maybe a little bit less. But we'll sort of see it come out on the graph as we go. So this is just the tool they give you to turn the dials. By the way, we're going to use an SSDev pick in 25,000s. It's one of the thickest ones I've got, and the springs in there are particularly strong. I'm going to start off by writing down the combination, mostly so I don't forget it, and also so as we do the graph we can see the combination come out in the possible digits that come out of the graph. So TR, BR, BL, TL, and that's top right, which is 5, so we'll put 5 in there. Bottom right is 9, and then bottom left is 3, and then top left is 9. So the combo 9593 is what I was given by Yona. Yeah, so we've seen how the key operates with that, so that is the correct combination. I'm just going to set all these to 0, and then we'll describe the method and crack on with it. So what we're going to do, so I'll start by saying I've not gutted this lock. I don't know exactly what's in there. It's kind of clockwork boogaloo as far as I can tell. I wasn't going to risk a fairly expensive lock to realise I couldn't get it back together. So the explanation I'm about to give may be slightly wrong, but it's based off what I'm feeling in the lock rather than anything else. So each of these combination dials is basically a cylinder, and they all have 4 gates, obviously 1 true and 3 false. So we're going to decode this in diagonals. So we're going to start by decoding this one, and we're going to put this in any gate. This we're going to rotate through the 9 and the 10 digits, and then we're going to use this one just to drop into another gate. hopefully, and what we should see is the core moves quite substantially when we're in a gate on this one. So because these, obviously this has 4 gates, this has 4 gates, this has 4 gates, we can put this in a gate, park this in a gate. So we park this in a gate, leave this on 0, leave this on 0, go through the digits, and then by moving this in and out of a gate, we'll see core movement. And it's fairly obvious core movement, so we'll end up the tension wrench pointing somewhere at the 7 on this dial. And that will throw out the gates in here, so we'll end up with 4. We'll just put X's in the column, and that will show us the 4 possible gates, and one of them is the correct digit for the lock. And then we'll leave this in a gate, and we'll do the same with this dial. So we'll pick the opposite corner. Let's say pick, I mean decode. So that will throw out all the true gates in in this dial. So we'll graph those, and then we'll pick the core the other way and do a similar thing, like park these in zeros, manipulate this one so it's in a gate, any gate. Go through this one, put this in and out of gates to sort of show that full set, and we'll graph that, and then we'll go back around and do the final one, and what we'll end up with is a graph with the positions of all the gates on each dial, and then that will give us 4 possible digits per dial, and then obviously 256 possible combinations. I think there's a little bit more to this as well, based on the thickness of the gates. I'm fairly sure that the true gate is either always before or always after one of the thicker gaps that come out on the graph. But we'll see if that comes out while we're decoding. So to start with, we're just going to leave everything in 0, and we'll get this this top stack picked. So we're probably going to end up picking this a lot in this video, if I can pick it at all. So you do need fairly substantial tension to pick this. There we go. So probably saw a tiny little bit of core movement there. So this is now picked. It passes the jiggle test on all the pins. So this is the first sort of weakness in this lock, is we can pick the top stack without having to know the combination. We can just park it in zeros and then pick the top stack, and there's enough slop in there to let us set the gates. Right, so we're going to put this in 1. 1 should work, and then just wiggle this around, and then there's no movement, so we'll put this one into a 1, and then we'll wiggle this around. No, so the first one is a little difficult. Basically, we need to find the opposing gates. You can tell that one's a little bit stiffer, so this may actually give us some movement now. Okay, so normally you would expect a gate to come out by now, so that probably means this is not in a gate, so we'll move it to 2. We'll try 1, and then we'll try, there's a little bit of movement there, but not the movement we were looking for. Put it in 2, no, put it in, don't want to go into 3, let's try that with something a little bit stronger. 3, there we go. A little bit of movement, but not what we're looking for. So we'll try 4. Nope. Okay. So what we're going to do is try the opposite cylinder. Sorry, the opposite dial. So this will sometimes either work using these 3, or we may need to use these 3 to decode this first one. So we're going to park that in 1 again. Hopefully that is a gate, and then rotate this. Nope. We'll try this one. We'll try this one. We'll try this one. No. So we'll try 2. No. No. It really doesn't like going into 3, so that's some feedback, but not the feedback we are looking for. Okay. So let's try going the other way. Let's put that one in 9. Do this dial. No. Let's leave that one in 1 and just see what happens. Try 2. So this is going to be a little bit of trial and error just to try and figure out where our gates are that might. Let's decode this dial. So a tiny little bit of movement there. So let's put that 1. There we go. So you see that movement's quite pronounced. So when we're on 1 on this, and we've got 1, 7, 2, 1. So these are probably all in gates now, but we'll decode those as we go. You see this is the dial that we're starting on. So yeah, we put it from 0 into 1, we wiggle this gate and we got pretty pronounced core rotation. So that is the bottom left dial, and I'm just going to put an X in 1. Okay, so now the hard part, we counter rotate out of there. We set that to 0, and then just test the pins and hope that we haven't unset anything. No, that looks good. Okay, so then we'll move this to 2, and we'll try the same thing. Got a little bit of core rotation, a little bit, but not as pronounced. It was as pronounced as the last time. Right. So this is why, because I'm actually in between 1 and 2. I failed to set the rotation properly, so let's put that back to 0. So now we're on 1. Now we're on 2. See, it clunked a bit there, so we are on 2. And then, yeah, we don't get any motion there. Let's check that top stack. Yeah, there we go. I didn't set one of the pins as well. So now we're on 2, give that a wiggle, nothing, 3, a tiny bit of core movement, and then again, big amount of core movement. So we shall put a mark in 3. Turn this back to 0, try not to drop any of the top stack. That into 4, a bit of a wiggle. Again, we got a tiny bit of core movement, but not what I'd expect. It's sort of, yeah, it's not deep enough that you can't sort of rotate that one without it, so we'll leave that one for now. And we go to 5. Make sure we're actually on 5. I want to wiggle, nothing, just test that top stack again. So yeah, that's fine. So I would expect 6 to be one that gives us quite a little deep rotation. Yeah, there we go. So put our mark in 6, and then again we'll just bring that one out of the gate, and see I have to manually kind of rotate that to let it work. That stack is fine. So again, we shouldn't get anything on 7. A tiny little bit of movement, but not all that much. It's go on 7 top stack. Yeah, I'm actually not exactly on 7, so this is something you do just need to be careful with, is that you actually line the numbers up properly. It's fairly easy to mess that up. There we go, and I done set a couple of the top pins as well. Okay, so that one, no, 8, yes. So put a mark in 8, and then we should see no more on 9. So put that back. So I have to manually rotate that again back to 0. And then we'll do 9, making sure we're actually on the number. Check my pins again. Yeah, you can quite easily unset a couple of these pins. So we're just going back through the stack. And then we'll try this one, and again, nothing. So look at our graph. We've got our 4 gates, and this follows this pattern, which we should see in all of them, where there's 1 space, then 2 spaces, then 1 space, and then 2 spaces between the 0 and between the next one. So we're going to now park this one in a known gate, so we know that 1 should be a gate. We're going to leave the other 2 exactly where they were. We're then going to decode top right. So we're going to do the same thing. We're going to pick this top stack. We're leaving these alone because we know these are in gates that actually work. So this is almost certainly in a gate, and this is the one that we're just going to flick in and out of a gate to trigger that motion. So yeah, we're going to decode this one. This one is in a gate that we know exists. Go through and just pick these pins again. So we're on 0, make sure we're lined up properly, and straight away that gives us fairly deep rotation. So this is top right, so we think it's probably a gate at 0. And then, so we'll just bring that out, pop that back on 0, move this to 1. And that gives us, okay, yes, this is a weird situation where I'm not even on the right number. Bear with me. Yeah, making sure we are actually on the number. And there we go. That doesn't give any rotation. Just check that top stack. So this is something you do need to watch when you're doing this, is that you actually, the gates are quite wide, so you need to make sure you're actually out of the gate that's on 0 before you test 1. Yeah, so 2 may or may not be a gate. 2 is more than likely a gate. And then knowing this pattern, our next gate should be on 5. So that means if we get 1 on 2 or 3, then we know we've probably not got these in the right spot. So we're going to make sure we turn this onto 3. Test the gate, nothing. 4, and making sure that is actually on the number. No. 5, I don't know if you can hear that click, but it did click quite audibly when we did that. And then, yeah, there's our next gate on 5. So right now we could probably guess that the next one is on 7, just because of this pattern that seems to repeat. I'm going to go through and manually test it, but yeah, you probably don't need to go through each combination. You could, once the first part of the pattern comes out, you could just fill the graph in. Again, nothing on 6. 7, again, we've got that slight click as we went into the gate. So yeah, 7. And then there shouldn't be anything else until we get back to 0 now, because that's all our gates done. Here's my other tool to rotate this one. 8. Yeah, nothing on 8. Nothing on 9. Just check that top stack, make sure I've not dropped anything there. No, that's all fine. So then we should end up back in a gate on 0. Yeah. So we've now done bottom left and top right. So we now have, in theory, we now have 50% of the combination. And if we look, we know the combination. So yeah, 5 has come out in this graph and 3 has come out in this graph. So we're doing pretty good. So we are now going to decode this one. So we're going to leave that one on that one. We're going to leave these two in gates. So we know that 1 and 0 are gates. This is going to be the one that we flick in and out of a gate as we test for movement. And we're going to just repeat the process with top left. But this time we're going to pick counterclockwise to allow the core to rotate this way, just because of the way the gates are aligning. We're going to do it that way. It is, for some reason, slightly harder to pick going counterclockwise. You know what, let's try it clockwise, let's see if it works. It should work. Rather than watching me fail to pick a 5-pin lock over and over, we'll just try it the other way. There we go. So this one and this one are in gates. This one may or may not be in a gate, and we flick this dial, nothing. Let's hope that it goes in. Yeah, there we go. So 0 wasn't a gate, 1 is a gate. So this is top left, so we put an X in there. And then we just counter rotate back that way. So yeah, we only need to pick one direction, which is nice. When I've been doing this previously, I've been picking counterclockwise, so that's good to know. So 2 should not be a gate. Yeah, what I've done there is moved it past into, it's not, yeah, I didn't move it out of 1. So let's make sure that we are actually on 2 this time. Yeah. 3, check that top stack again, just in case we dropped anything. There we go, I did drop something, that's good. So 3 may or may not be a gate based on our pattern. Doesn't look like it. 4, yeah, so 4 is our next gate. So we can put an X in there. So now we should be able to just fill this in. So 6 should be a gate. You know what? Let's fill it in and then we'll test it. So 6 should be a gate. Then there should be a gap of 2, and that would mean 9 is our gate, which gives us 0 is the space, and then 1 is the next gate. So yeah, this is should be a fairly quick method to decode this once you sort of figure out the first 2 gates. But obviously, because this is essentially a public first, I'm going to just go through it and verify my claims. Yeah, so that's 4. So now we turn this one to 5. Make sure we're actually in 5. As expected, nothing. So turn that to 6. You can hear an audible click. Make sure we're actually in a gate. My top stack dropped. No, that looks okay. Let's make sure we're in there. Oh, there we go. I need to turn it the other way. That's fine. 6 is a gate. We've already recorded that one. switch that one out there. Check pins again. Yeah, managed to drop one. Okay, so set this one to 7. See, it was quite hard to get out of that gate, so yeah, that's fine. And then set it to 8, which should also not be a gate. Yep. And then 9, you probably saw the tension wrench move a little bit there. Yeah, turn that ever so slightly and we're in a gate. So we've now, and again, yeah, our known combo has come out on the last gate, that one. So we only have one left now, we just need to do bottom right. So let's just reset that. So we are doing bottom right, so we are going to park this one on 0. We're just going to use this one to flick in and out of gates to test the rotation. We'll put this one on 0 and we're going to leave these two in known gates because that will give us enough slop to allow the rotation to happen. And then we'll pick the top stack another couple of times. Hopefully. There we go. Okay, so we test for a gate on 0. We'll just flick it in and out of, yeah, probably not. Make sure we're on 1. Nope. 2. So we know from our first graph, I think, that 2 is more than likely a gate. So we should, yeah, should see some movement on 2. So we'll graph bottom right, plus 2. Just ever so gently counter rotate that out, and then make sure we're on 3. Yeah, nothing on 3. So 4 may or may not be a gate. Looks like 4 is a gate, so we'll put a cross in 4. So that means from our pattern, the 5 and 6 shouldn't be a gate. 7 should be a gate, and then we've got a gap of 1, and then 9 should be a gate. So let's double check that that is the case. Make sure we're on 5. Just check the pins haven't become unset. There we go. Just give that a flick. Yeah, that's not a gate. 5, 6. Make sure we're actually on 6. Not a gate. So 7 is a gate. And then we'll just take that back out of there. Check our pins again. And they're good. And then make sure you can feel the click when you're the edge of one of these gates, and some of these are set. You have to give it a little bit of a turn to get it out of that gate. So 8 is not a gate, and then 9 is a gate. So take a look at our graph. Make sure we can see this properly. There we go. So you can see we've pulled out the gates, like the 4 possible gates for each dial. And for each of them, like so 5 was a gate and 5 is a combo, 9 and 9, 3 and 3, and then 9 and 9. So right now we have 256 possible combinations, right? We could just go through each of these, like 4 possible digits per dial, 4 times 4 times 4 times 4 is 256. So we've dropped that key space from like 10,000 to 256, which you could probably rattle through in a couple of minutes. But I think we can actually do slightly better than this. So if we look at these numbers, and this is, I've not got enough of a sample size to say definitively that this is true, but in the 2 graphs of this I've done, the true gate, let me circle the true ones just to make this a bit easier. So circle on that one, that one, that one, and that one. So these are our known true gates. And they are always, like, so there's a gap of 1. There's 2 gaps of 1 and 2 gaps of 2 in these. And these are always before or after one of the gaps of 1s. So that removes some of the possible places it could be. So, like it, does it? No, it doesn't, does it? I think I'm talking complete nonsense. Well, that's fine. I'm not about to re-record this. So yeah, so we have 256 possible ways of decoding it. Yeah, I'm fairly sure of enough sample size there is a pattern between the gate positions and where the true gates land. But for now, I'm going to call this partially decoded. Yeah, for me anyway, we've dropped the key space enough that brute force is now realistically possible in a short enough amount of time. And yeah, we've definitely got the correct digits come out in our true gates, but I will set this to this known combo. We'll pick it one last time and just sort of show that it is in fact open. So top right we want to set to 5. Set you all the way around. Bottom right we want to set to 9, which is already on because that was the gate we were testing. Bottom left we want to set to 3. And then top left we want to set to 9. And then we should just be able to pick this one more time and call it open. And of course now at the end I can't pick a 5-pin lock on camera because, you know, obviously. There we go, and our lock is now open. Yeah, so that is, and as far as I know, previously unknown decode method for the Sezam lock. So I'm going to, I'm not going to gut this, but I am going to take the back plate off and just sort of show you why I think this method works. So yeah, let's take these screws out of here. Okay, so let's use the key. It goes in. So these are all still set to their correct combination, which means we can now change the combination. There we go. Focus, focus. Yeah, man. There we go. So these are the back of the dials. And you can see there's 1, 2, 3, 4 gates in there, and the thickness of the gates is different. So if I'll try and rotate one. Okay, let's do this one. Of course I can't rotate it because the lock is open. Yeah, that's why this attack works. So there's enough slop in these gates when they're all in any gate that you can sort of move the core and decode where the gate positions are. And then yeah, one of those gates has to be a true gate. So that reduces the key space quite dramatically. Yeah, let's take the key out of there. And try turning one of these gates just so we can see what it looks like. So yeah, as I turn it, you can just sort of see this gate that's coming around now. This one, this is the true gate. So you can kind of see the gap between them is different. So that's quite a wide gap, and then there's quite a narrow gap. Then there's quite a wide gap and quite a narrow gap. So I'm pretty sure with enough sample sizes you could figure out a relationship between like the gaps, like the width of the gap in between the gates. But yeah, for now this will have to do. That was the Sezam combination lock picked and decoded.